Okay, so we're now going to start to talk about the scope of inference in a statistical study. So, kind of like after doing a survey or an observational study, what can you actually conclude? And likewise with experiments. So, let's just kind of quickly recap what we know. So, for surveys, um, random sampling avoids your bias and produces trustworthy estimates of the truth about your population. So, because of that, it's safe to make an inference about the population, but you can't infer about cause and effect. With experiments, random assignment helps ensure that the two groups of subjects are alike as possible before the treatments are imposed. And so, because of that, you're actually seeing if a treatment has an effect or not on a response variable, right? So, because of that, you can make an inference about cause and effect. But because you just run the experiment on a very um, small population that are very similar, you can't actually infer about a larger population with an experiment. So, well designed experiments randomly assign individuals, but most experiments do not select experimental units from a larger population. So, usually, like you can ask for volunteers that fit certain criteria, um, but they're similar. They're similar within, so you can't make an inference about a larger population. With an observational study, um, uh, does not randomly assign individuals. Random selection of individuals allows inference about a population, but you can infer about cause and effect. So one you could do one and not the other, and vice versa. So a well-designed experiment randomly assigns individuals to the treatment. So let's take a look at an example of where we see this. So this is just kind of a chart showing you what you can do and what you can't do. So the individuals were randomly assigned to the groups versus were individuals randomly selected. Okay, so here's an example of vitamin C and canker sores. So a small town dentist wants to know if a daily dose of 500 milligrams of vitamin C will result in fewer canker sores in the mouth than taking no vitamin C. So the dentist is considering the following four study designs. The first design, get all dental patients in town um, get all patients in town with appointments in the next 2 weeks to take part in a study. Give each patient a survey with two questions. Do you take at least 500 milligrams of vitamin C each day? Do you frequently have canker sores? Based on the patient's answers in question one, divide them into two groups: those who take at least 500 milligrams of vitamin C daily and those who do not. So, with this design, what can the dentist conclude? Well, because the patients were not randomly selected, the dentist cannot infer that this result holds for a larger population of dental patients. This was an observational study because no treatments were deliberately imposed on the patients, with no random assignment of the two groups. No inference about cause and effect can be made because it's an observational study. So the dentist just knows that for these patients, those who took vitamin C had fewer canker sores than those who didn't. So not much can be known from this first design. Okay. Design 2. So get all dental patients in town with appointments in the next 2 weeks to take part in the study. Randomly assign half of them to take 500 milligrams of vitamin C and the other half to abstain from taking the vitamin C for 3 months. Okay, so in this design, as in design 1, the dentist can't make any inference about this result holding for a larger population of dental patients. However, the treatments were randomly assigned um, to the subjects, which means it's an experiment. So, assuming proper control in the experiment, we can conclude that taking vitamin C reduced the chance of getting canker sores in her subjects. Okay, design 3. Select a random sample of dental patients in town and get them to take part in a study. Divide the patients into 2 groups as in design 1. Okay. So now this time, because the patients were randomly selected from a population of dental patients in town, the dentist can generalize the results of this study to the population. Because this was an observational study, though, no inference about cause and effect can be made. The dentist would conclude that for the population of dental patients in this town, taking vitamin C, those patients taking vitamin C have fewer canker sores than those who don't. She can't say whether the vitamin C causes this reduction or some other confounding variable. Design 4, select a random sample of dental patients in town and get them to take part in a study. Randomly assign half of them to take 500 milligrams of vitamin C each day and the other half to abstain from taking vitamin C each day. Okay. So in this last design, as in design 3, random sampling allows to generalize the results to the population. As in design 2, the random assignment would allow her to conclude taking vitamin C reduced the chance of getting canker sores. So the dentist would conclude that for the population of dental patients in this town, those taking vitamin C will tend to have fewer canker sores than those who don't due to vitamin C. Okay, I'm going to do one more video for the last one.